Okay, so everyone, welcome back to vJUG24. We are, what are we on now? 24, 23, 17. We are on session 17 of 24, still going strong. Just started on the Americas region. And our session here is the keynote for the Americas region, an overview of Kotlin for Java programmers, and we're very delighted to be able to welcome Bruce Eckel to the virtual JUG for the first time. So Bruce, welcome to the vJUG.
Thank you. It's very interesting so far.
Awesome. Well, it's our pleasure to have you here on board. Our sponsor for the session is Sonatype, and participating JUG is the Montreal JUG. And is this the first time you've joined vJUG24?
Yeah, first time.
Awesome. So tell us a little bit about your JUG, Henry.
It's in Montreal. We meet about once a month. The good thing is all the good speakers in the world wants to go to Montreal and they never went. So we managed to get them quite often these days. So we're really happy about that. Bruce, you can come live whenever you want. We're about, like, I don't know, 1,400 members. And here you got 100 people, I guess. So it's pretty fun. What else can I say? We're sponsored with that Oracle building. So Oracle is giving us the room, which is nice of us. And we have some sponsors like Software AG and Chromas.
Nice. Nice. And how old is the JUG?
Sorry?
How old is the Java user group?
I've joined to get... Oh,
I think...
Mathieu?
Yeah, it's 2000, David? 2006?
Yeah, no, the founders is so old, the founder doesn't even remember.
Actually, which is the other JUG member just
yeah, it's about 10 years. 10 years old, I guess. I think
the founders are now Kotlin developers, and they're running a Kotlin user group now, are they?
Now the one is turning to front end, is doing JavaScript or things like that.
You can say 2005, 2006, somewhere like that. We have revived it because it was dead for some several years. So it's a lot of time now.
Awesome. Well, welcome. We'll look forward to questions and things like that during the session. We also have Roberto. How are you doing, Roberto?
I'm fine, and you, Simon? Did you rest?
How are you holding up?
I'm fine. I just rest for the last 8 hours, so.
Oh, okay, good. Also, a big shout out to Ivanov, who's actually been working in the green room. He's pretty much just done his last shift of vJUG24. He's pretty much been doing it from the start. So he's one of the people who's been helping Java user groups and speakers get onto the session. So, but hopefully you can see my screen. So what can I say? Let's give a quick slide to Sonatype for being our sponsors. They're actually our gold sponsors. And Sonatype Nexus, obviously the repository, the world's best way to organize, store, and distribute software components. So it's certainly a very important part of anyone's deployment to have some kind of repository like Nexus. So do check that out and look after our sponsors kindly. So please go and visit their site and check out Nexus. Obviously Zero Turnaround as well, sponsors of the virtual JUG. And if you wanted to interact with this session, actually I'll tell you a little bit about how we're going to run this, because I was really keen on getting Bruce Eckel here as a keynote speaker, and he mentioned he's in an area. Well, why don't we talk through it, Bruce? You're in an area with a very poor broadband or bandwidth, right?
Sometimes it goes out. Actually, the broadband that I have is pretty good for this area, but I'm way up in the mountains, in just off the Continental Divide in the Rocky Mountains, and so and it's a small town, so it's taken a while for faster internet to get here, but it's actually decent now. So.
Yeah. Okay, cool. So what we did as a backup is we've got a video of Bruce, which is very kindly recorded just a few days ago, so that if we do have any problems, we've still got that video, and Bruce is going to be available for Q&A as we go. So if any questions from the Montreal JUG, please shout them out, And any questions on Slack, if you have them, feel free to drop them into the live session channel. If you wanted to join our Slack group to ask those questions, if you go to vJUG24, just beneath the video, there will be the live session, there will be the Slack image. Click on that, you'll get into our Slack, and then just ask any questions in live session. You're obviously free to tweet with the hashtag vJUG24. And for those of you, obviously this is a new stream now, so make sure you've cranked up your video quality to as high as it will go. So just click on the settings cog and choose the highest resolution you can there. So without further ado, I'm actually going to do a couple of things. I'm going to drop off this Hangout. Hopefully this is going to work fairly nicely. I am now going to switch over to this machine. I'm going to share a window. Here's our session. If we have any questions, I'll pause this straight away and we'll jump straight to Bruce. So let's get started.
Hey, I'm Bruce Eckel, and I'll be giving a Kotlin overview that assumes you're already a Java programmer. Before working on this project, I spent 2 years working on this book on Java 8, which covers everything about Java 8 in pretty thorough depth. It's only available as an ebook. It's quite large, so making it a print book would have been problematic. And you can find it at this URL. The examples from today's presentation are from the upcoming Atomic Kotlin book, which I'm co-authoring with Svetlana Isakova. She started out as a member of the Kotlin compiler team, and she is now a developer advocate, and she trains people in Kotlin. For me, the short version of Kotlin is that it fixes pretty much all the Java annoyances that I've had with the Java language. Even Java 8, which has been a huge step forward, still has a lot of chains that it's dragging around from early poor Java design. And Kotlin just basically covers over all of these. And so you don't really have to worry about the fact that you're dealing with Java underneath the covers. Kotlin seems to try and do anything that it possibly can to solve these problems. And at the same time, it interacts and integrates very easily with Java. One of the benefits is that it runs on the Java 6 JVM, if that's what you've got. So you get all the advancements of Kotlin, but you can still, if you're still stuck with Java 6, you get to jump forward. And this is one of the reasons that Google chose Kotlin as its second official Android language. Java 6 is the first language, and Kotlin is now been adopted as its second language because it still works with Java 6, but it allows you to jump forward with language features. One of the significant benefits of Kotlin is that it enables a much better style of functional programming than even Java 8 does. And again, Java 8 has made some big important jumps forward, but Kotlin's style of functional programming is much nicer. One thing that you have is invariance by default. In most cases, everything is invariant if you don't specify that it's mutable. Kotlin has first-class functions that are quite easy to manipulate, which is essential for functional programming. And as you'll see, the lambdas are far more useful. They don't have the restrictions that Java 8 does. They're truly closures. They are not partial closures. And the syntax is much nicer, as we'll see. So let's start out by looking at some simple code, just examining the basic syntax. And the first thing that you'll notice is that Kotlin allows you to have top-level functions. So here's, for example, a function which we define using the fun keyword, and the function name is cube, and we have the argument list. And you'll notice that in Kotlin, as in a lot of more modern languages, we see the identifier first, followed by the type. And so here x is of type int. We see the close parens, and then the function type itself, what the function returns. We again see a colon, and this function type is int. And then we see the familiar open curly braces, and we return x times x times x. So that's pretty familiar. But notice also that there is no closing semicolon. Kotlin does not require semicolons. It can figure out when an expression is finished, so it doesn't need you to put in the semicolons. There's a second form of function, which we see here with bang, and that is using the equal sign and a single expression. And so notice here that although we're passing in an argument of a string, we don't specify the return type, because one of the things that Kotlin has is type inference. And so it is inferring the type of the function, which is, in this case, a string. And all it's doing is returning the value of s plus an exclamation point. And notice in the case of the single expression function, we don't need to use the return keyword either. So there's a lot of small functions that you write, and this form is quite convenient and straightforward. And you'll notice that a lot of Kotlin features eliminate a lot of the visual noise that you get with all the extra Java stuff. So, for example, here we don't have to use classes if we don't want to. These functions exist at the top level. Of course, underneath the covers, it's probably creating classes because Java is based on classes. Finally, you see the main function, which again doesn't have to be inside of a class, and the default argument list is an array of strings. And here, another lack of noise feature is println. Instead of having to say system.out.println everywhere, you can just say println. One of the nice features in Kotlin, this is a fairly simple one, is string templates. And you see this in languages such as Python, where it's very easy to perform substitution of identifiers into a string. So here we have a val answer. And notice, again, I don't declare the type. I could say val answer colon int equals 42, but Kotlin performs type inference, and so it knows that answer is an int, and I don't have to declare it everywhere. And inside of a string, if you have a $sign and then an identifier, it will go ahead and produce and insert that substitute answer in for this expression. And you can see in the output it says found 42. You can also create expressions inside of strings, as we do here, with a $sign and an open curly brace. And inside the curly braces, you can put whatever expression you want. So it's kind of like a templating language. If you put in something that it doesn't recognize as an identifier, it'll simply print that out. Also, there are no constraints on file names. In other words, the way Java does it, where you have classes and you have to have the file name as the same name as the class. You don't have that constraint in Kotlin. Here's a nice feature that they added in terms of strings. We have triple quotes, which at least the first place that I saw this was in Python. So anytime you have triple quotes, this includes new lines and single quotes and everything inside of the triple quotes. So just a small but nice feature. There are no primitives in Kotlin. In other words, we don't have to worry about wrapping types or converting from boxing and unboxing and that kind of thing. So here we have 3 vals, and I don't think I mentioned it before, but vals are automatically invariant, so I can't change what's in n once I assign it. And so the default is an int with a capital I. If I specify with a trailing L, I get a long. If it's got a decimal point in it, it defaults to a double. So this is just one of those things where it's removed a lot of the hassles that you get with Java and having to mess around with primitives. Iteration is quite nice. Here is one way we can do iteration using the in keyword. So I'm saying for C in Kotlin, and what it's going to do is it's going to treat each letter of the string as one element. And so here we print each one out with a space after it, and so we see the result here. One of the things, notice that I don't even say that this is a var or a val. I just throw in this character C, and it automatically treats it as a character, and it treats it as an invariant. It treats it as a val. So each time through the loop, it doesn't allow you to change it once you're inside the loop. Kotlin has nice support for ranges. This is one way you can do it. You can just say 1.10 and it gives you everything inclusive. There's a bunch of different support for other forms of ranges, but it's just one of those things that makes using the language nicer and easier to understand. It has a feature called named and default arguments, two features actually. So we have arguments, and we can give them, this is the nice thing, is we can give them default values, and when we call this function getColor, if I just give it one argument, it treats that as the first argument. I can also specify that I want blue to be the argument that I'm handing it, in which case it leaves the others with their default values. I can give it 2 arguments, in which case it's substituting the first and second ones. And I can, here's another example of specifying the arguments by name. So not a huge feature, but especially when you have long argument lists and you don't want to have to, either you want to be very clear about what the argument is, and or you don't want to have to give all of the default arguments if you're not using them. It's very nice. Lists are, well, I call them first class.
Just a question in for Bruce here. I don't know if the Montreal Jug's got some questions as well. Question in on Slack. Philippe asks, are the string templates from the slide ago, are they pre-compiled or are they evaluated at runtime?
Well, I think there is some pre-compilation, but since you're actually substituting values, that has to happen at runtime. But for example, the expressions, the compiler would do some pre-compilation.
Okay, awesome. Thank you, Philippe, and thanks, Bruce. Any questions from Montreal Jug so far?
Questions? All clear? They all really scholar here. Everybody's listening.
That's great. We'll continue that.
It does simply mean that we don't have to import anything in order to use a list. And when we create a list using list of, we get a immutable list by default. So I can't change the elements in the list, but we have support for indexing. So here we see square brackets to index into the list. If it's a mutable list, then I can also use square brackets to write to it. If I use some of the operations on the list, what it does is it creates a new list for each one. Here I'm also introducing a new concept, which is this EQ here. This is from the book. What we've done is we've created an infix operator called, I'm sorry, it's not an operator, it's an infix function called EQ. And so it allows us to write this expression. Here's what L1 reversed is equivalent to this list. This is an example of how easy it makes Kotlin to create domain-specific languages. And this is just a small version of that, but it is a very helpful feature because often you'll want to make a domain-specific language for someone else to use and to make their life a bit easier. Classes can be defined. In this case, I define a class and it doesn't have any body at all. You don't have to put curly braces. You'll see a theme here, which is that Kotlin is a very minimal language. It's designed to, remove all possible noise. If I do have a body, I put it inside of curly braces, and here I'm putting simply a value inside of here, which can be read. Here is a class that contains a list. And you'll notice here's how the constructor works. There is no new because technically new is redundant. That was just something that it got accidentally transferred from C++ to Java, even though you basically create all objects on the heap. And so it was a redundant thing to have. So when we create an object, we simply put parens after it, and inside the parens we put any constructor arguments that we need. Kotlin has a very nice feature called a data class. It's similar to a feature that you might have seen in one or two other languages. The nice thing about the data class is that it's something where you're creating a class that you simply want to hold some data in it. And the data class will automatically create all these different functions, a lot. It basically does everything that you would need to do, but it does it all for you. And so you need to specify your arguments, but then it turns those into properties for the class, which can be read. And if it's a var, as in this case, you can also write to it. So I've got arg1 and arg2, and then, for example, when I display it, I will get the output, which is just showing us the arguments for you. And it created that toString. And you can override these things if you want to, but the nice thing about the data class is it does it all for you. So extremely useful because a lot of time in Java is spent in filling out what the equivalent of a data class would be.
We have a question here.
Hello, Bruce.
It has something called an extension function, and a lot of times that you use inheritance.
We need to pause it first. Okay. Go ahead.
Oh yeah, sorry, I didn't notice it was a video. Hello, Bruce. I just had a question on the previous slide. When you were using a var for your data class, that means that there's also setters that are generated for this variable.
When I used a var, yes.
Okay.
And both of these are initialized when you create an instance of a simple, in this case. But later, if we want to, we can say like s1.arg2 equals 4.
Yeah.
If we want.
Okay. Okay. Thanks.
Yes, and it creates. Yeah, it creates a setter for you.
Okay, thank you.
Yes.
Thanks.
Any other questions? All good? Cool, thank you.
And a lot of times that you use inheritance in Java, it's some of the cases is when you want to add new methods to an existing class. You inherit from it and you add those methods. And Kotlin picked this feature up from C#, and it's actually quite a nice feature, and we see a version of it in the Go language as well. So when we have I'm creating a data class here, and somewhere else, maybe somebody else has created this class, and I want to add a method to it called categorize. And what I do is I define a function as I do before, but instead of the function just being a regular plain old function, I precede it with book dot. And now this function becomes associated with the book class. And so if I create a book object, as I do here, now I can call this method by just simply saying dot categorize as if it was any other method. Actually, we call these member functions in Kotlin. So they just use the term function everywhere. And inside of a class, it's a member function. But sometimes, out of habit, I'll slip into calling it a method. So when you're inside one of these extension functions, you still have to follow the rules that are established by the class. Like if something is a val, I can't change it, and if it's private, I can't look at it. But in general, this is a super useful feature, and it's surprising. It looks kind of simple at first, but it's surprising what extension functions actually enable for you. But that's a topic that requires more depth.
Does this question in from Slack, this book class, is this missing? Is it just a typo that this is missing a open curly brace after the book?
No, this is a data class like I showed before, and if I don't need to do anything more than put data elements in it, which is all I do here, I don't need curly braces after the class.
Okay.
Everything. So again, if this is the way Kotlin works, if it doesn't need something, it doesn't force you to have it.
Perfect, thank you. Second question from Rufai. Does the ordering of the functions matter? As in, does the book.categorize have to precede its use?
You know, that's a good question. I don't think so, but I haven't really played around with that. That would be an interesting, I'm pretty sure it doesn't. Yeah. But, you know, having not tested it myself, I hate to say something like that deterministically, but just everything else about Kotlin would suggest to me that it doesn't matter.
Yeah, I think, I mean, I haven't played with Kotlin for a while, probably maybe a year. But from when I was playing with it, I'm sure I would have tripped up on that if it had some.
That's pretty basic.
Yeah, yeah. So I think it's it doesn't care about the ordering. Cool. Thank you. Any questions from Montreal?
Questions? No, all good.
Cool.
See it when the book comes out. Kotlin has a feature called pattern matching, which uses the when keyword. And here's one form of it. There's actually many different things that you can do with pattern matching. And in this form, all I'm doing is I'm taking the argument and I'm matching it with red, blue, green, or something else. And I'm producing from this, notice we're using a function with the equals. And this is a single expression here. And so I'm producing from this expression the result, capital red, blue, green, etc. So, but there are a bunch of different things that you can do. You can test for types or values or all kinds of other things. So pattern matching is very powerful. And when you compare it to the kinds of things that you typically have to do with if statements, it's much more succinct and easier to read and understand. Kotlin has local functions, which means I can define a function inside of a function, which is what I'm doing here. Inside of main, I decide, you know, I'm doing this exclaim thing a bunch, and you know, perhaps I'll want to change it here and there. So I'll define it as a local function and then just reuse it within main, and it's only visible within main. In this case, the local function is an extension to the built-in string class. So anytime I have a string, I can call my exclaim function, member function, for that string class, or at least that's what it looks like. So this is very useful simply to simplify your code and to stop repeating yourself. Kotlin has really no support, I think.
If I can. I'm not sure that I got it, but when you do something like that, can you access the internal attributes of the class?
No. Well, let me correct that. You can't access private attributes, but you can access. You're basically whenever you're using an extension function, you get a this, which is the object that you're acting on. So you have a string that you can work with, and so let's see. I'm blanking a little, but I think it's actually this that you get as the object that you can act upon. So if the internal elements are visible, if they're not private, then you can definitely access them.
Okay, there's a concept of protected, or
no, it doesn't. It doesn't do protected, and there's a reason for that, which I wrote about too long ago, and it's not on the tip of my tongue. But yeah, that's a little deeper in the way, in kind of the Kotlin philosophy. You can do inheritance and polymorphism. Well, I think we actually have an example here later, but extension functions sort of, and the way that you do inheritance and polymorphism kind of pushes you away from doing it for any other reason than polymorphism. So in the cases whereas, I mean, you could say in Java you're doing inheritance all the time, whether or not you're doing polymorphism. With Kotlin, if you want to do it, you can, but you have to be very intentional about it. I hope that helps.
Yes, thanks.
Got a very good question actually here as well from Rufa again in the Slack. Can an extension function override or redefine an existing function with the same name?
I don't remember. The Kotlin documentation is actually really good. If you Google for it, you often land in the Kotlin docs as your first link, and they've really put a lot of effort into making it clear and easy to understand. So if you hunt for that, you'll find it. I just can't recall off the top of my head.
And how do the scopes work for extension methods? So here you've got on the previous slide, you've got an extension in a method before it was outside the method. Presumably that means that only code in the scope of that method can access that extension, right?
Right, just as you would think. Most of the time, your guess is the correct answer.
Okay, awesome, thank you.
Null safety. So when I create S1 here, it's assigned to a value, ABC, and it's a val, so it can't be modified. I can't change it to something else. So in this case, S1 is null safe. It's not ever going to be anything. It's not ever going to be null. Whereas S2, the way that I'm defining it here, if I define it with a question mark after it, that means that it could be null. And here I happen to be assigning it to S1, which isn't null, but the fact that I put the question mark after it tells the compiler that S2 must be treated as if it might be null. So with S1, I can simply call operations on it, and it's happy. With S2, if I called the same operation on it, because it could be null, the compiler won't allow this. It says you have a risk of this thing being a null, so you can't do this. So if you have a nullable type, which is what we see here, the string question mark and the int question mark. So S and len are both nullable types. So if you have a nullable type, when you use it, you have to somehow do a null check on it. So here I'm checking to make sure that that's not null. And if it isn't null, I go ahead and call length. Otherwise, I produce a null for this expression here, which gets assigned to length 1. And so the compiler is happy with that because I've checked for null. But since this is something that you do a lot, it has a shorthand syntax for it, which is the question mark dot. So if I say question mark dot, I get the same effect as saying if this is not null, perform the operation, otherwise produce a null. So, and there's significant additional support. I'm just touching the surface of the null safety here. So let's have a look at lambdas. Here I can create a list. We've seen the list of creation before. So I've got a list of 4 elements. And then I can call, for that list, I can call a member function called for each. And I will pass for each this lambda. Okay, so we can see that a lambda is inside of curly braces. And we have the argument list separated from the code, the function itself, with this arrow. And then here's the function. So what I'm doing is I'm taking each one of the elements is going to be placed inside of n, and each of those elements I'm going to surround with curly braces and turn into a string and append to s here. And so at the end we see the result of s. Okay, so a lambda is a function that we define using curly braces, and its arguments are separated by the function code itself with an arrow. So now that's pretty nice, but there are simpler ways. Oh, I should point out something else. Notice that s is outside of the lambda, and it's a var, so it can be modified, which is what we're doing. And so what we're seeing here is that the lambda is a true closure. All right, but look at this code here, and now I'm going to simplify it. First thing I'm going to do is I'm going to take the list and turn it into a range. So now I've got this range, and I still have the for each, but now notice that if the argument, if the lambda is being passed as the last argument, you don't need parens. And so I've removed the parens and simply put the lambda in here. So I've got s plus equal. And notice also that I've removed the argument and the arrow. So if you have a, oops, wrong way. If you have a single argument, as we do here, you can just use the reserved keyword it as the argument. And so I don't need the n and the arrow as I had before. So this is a nice simplification that you can have. So now let's look at a lambda that has 2 arguments. So the for each index produces an index and the character for each one. And so we now have 2 arguments, and then we need the arrow, and now we can go ahead and put these in. So that allows us to, or that's just a demonstration of what multiple arguments looks like. So lambdas are very simple and straightforward, and you don't have to run into surprises, or you don't have to learn any special rules about them. They just work, which is really nice. And one of the things that they allow you to do is this functional chaining that you often see with functional programming. So here I have a sequence, and I'm going to map each element of the sequence onto this expression here. So we're going to turn each number into a square bracket surrounded string. And then that produces a sequence of those, and then we're going to call the reduce function, which takes its first argument and gives it its default value. And here's the second argument, which is each one of the elements from the stream, and it's adding the second argument onto the first. So that's what it means by reduce. Maybe reduce should have been called combine, and we get this this string. And there's all kinds of other operations to produce this functional style chaining so that you can get this effect, which we've seen in Java 8. It just is simpler and cleaner in Kotlin. Plus, it works as far back as Java 6. So Kotlin has operator overloading. When Java was created, they were looking at C++. C++'s operator overloading is in fact quite complex because objects can live on the stack or on the heap. It turns out that if objects only live on the heap, operator overloading is much simpler, but they basically threw the baby out with the bathwater on that one and said, operator overloading is bad. Scala went to the other extreme and it said, we'll allow you to invent new operators. And that was probably a good experiment because we know where that can go. So Kotlin's operator overloading basically follows the pattern that Python uses, which is, first of all, there's a limited set of operators you can overload, just the ones that you expect, a known and constrained set. And you overload the operators using words. So this means it's very easy to search for overloaded operators. You can find them easily because they are overloaded by words and not by characters. So here I've created a data class called num. I've used the operator keyword to define an overloaded function, num.plus. So I'm using, again, an extension function. And it produces a new num with the values inside. And so we can see num4 plus num5 equals num9, etc. You can also explicitly call the plus if you want to, if that helps. So operator overloading is very available and simplified. It's not that you use it all the time, but there are times when you need it and you don't want to go down a rabbit hole when you're trying to use it. Here's something that has always been a little bit of a puzzle for folks when they first encounter it, which is that if I have a list of animal and a cat is a type of animal, I can't just assign a list of cat to a list of animal. It considers them incompatible types. And those reasons, you can make the arguments, and a number, both C++ and Java work this way. But the argument never quite makes sense because you're thinking, well, if it's a list of cat, it should also be a list of animals. So why doesn't that work? In Kotlin, we do get automatic covariance. And there's a number of interesting things going on here. One, I'm creating a class animal, which I have to create as an open class because I'm inheriting cat from animal. And when I inherit from a base class, I have to provide the constructor argument list after the name of the base class. So that's what's going on here. If you don't make a class open, you can't inherit from it. So this is a way that Kotlin sort of pushes you more towards using other approaches. If you really want to inherit and use polymorphism, you certainly can, but you have to be very intentional about it. So now, if I create a list of cat, and notice I've actually declared the type of cats as a list of cat, I can simply go ahead and assign it to a list of animal, no complaints. So we have automatic covariance in Kotlin. Generics in Kotlin.
Can I ask a question? Sure. Okay, the lists are immutable?
Yes. And by default, it's if I don't say anything, if I don't say anything else, unless I explicitly create a mutable list. So in this case, list of is automatically immutable. So once I create it, I can't add or remove animals to that list.
Because what happens if you try to add a dog to the cat list?
Well, if you try and add a dog to the cat list,
Let's say it's mutable.
Say it's mutable. If you try and add a dog to the cat list, you'll get a compile time error. Just like you would expect.
To animal list. Can I add dog to animal list?
But you could add a dog if, I mean, in this case, I can, you can see I'm adding dogs and cats together to a list. And the type of that list is a list of animals. If I had only created a list of cats, its type would go to it would treat it as a list of cats.
Okay. Yeah, it's really upside down compared to Java. Okay, thanks.
Yes, I know. You have to kind of figure out, jump through some hoops to be able to mentally fit it in your head, but this is the more natural way to think about it.
I was just going to say, which is the upside down one?
Yeah.
Yeah. Thanks.
To be easier and more powerful. So, and there's a lot of operations that you can perform with generics. So here I've got, as an example, I'm using the filter is instance. So if I have a list of animals here, different types of animals, and again, well, in this case, I'm using the interface keyword, so it doesn't have to be open. And I'm defining cat as a data class and dog as a data class. Both have the same interface animal. So this list of animals is going to be a, because they're dogs and cats mixed together, it'll just be a list of animals. Now I can perform a filter is instance, and it'll actually look for instances for me of cats and dogs. And we can see it actually produces a list of all the cats and a list of all the dogs. There are a lot of functions like this that give you a great deal of power in not much code. So this is the kind of thing that you get often with functional programs is a few lines of code do a lot of things that would otherwise require you to write a lot of code in other languages. So Kotlin has a lot of other powerful features. I mentioned a little bit about domain-specific language support, and this can be very convenient. Even if you don't create a full DSL, just the tools that we created for testing in the book was very nice. They have a feature called delegation both for classes and for properties. It supports both lazy and late evaluation. So if you don't think you're going to evaluate a certain piece of your code unless something special happens, and it's an expensive evaluation, you can make it either lazy or late. In Kotlin 1.1, they introduced coroutines, which I'm still coming up with the learning curve on those. And there's a lot more. And in general, if you start studying this language as I did, I was skeptical at first. I had seen some very early versions of it and the early things did not impress me, but what I've seen now looks completely different from what I saw back then. So if you took an early glimpse at it and weren't impressed, please do revisit it, because I have to say it would be hard for me to think about going back to Java after learning Kotlin. And the book's URL is atomickotlin.com, and please check in periodically. We haven't got much there now, but we hope to finish the book around the end of the year, and the ebook would be available quite soon after that, and then there will be a print book a month or two later. So thank you very much for listening, and we should have plenty of time for questions.
That's awesome. Thank you very much. Actually, we don't have a huge amount of time for questions because we've been taking them as we go. But I'm sure we've got some more. We have probably about five or 6 minutes before we switch to the next session. So, any questions online Slack? Please drop it into the live session link. Live session channel. Josh Long has sent you on Twitter an amazing GIF, Bruce, saying that cats and dogs can't live together. It's mass hysteria. But any questions from Montreal?
Yes.
So I'm curious about Kotlin's relationship to other frameworks in Java, whether it's FX or Spring or the whole farmyard full of them.
Boy. I have no. It's just I haven't looked into that. I'm focusing. I mean, this book is an introduction, and so I mean, like today, I was struggling with delegation and kind of getting a deeper understanding of it. So I don't know anything. The one thing I do know is that much more than Scala, Kotlin has gone out of its way to be very easily compatible with Java. And to the point where it's reasonably transparent. So I would guess, not having tried it myself, I would guess it would be fairly easy. I mean, they want you to be able to use Java libraries very easily. So I would guess it wouldn't be very hard, but not having done it myself, I don't want to guarantee anything.
Yeah, I can back that up actually. I played with Kotlin and Spring, and it just seemed to work. I'm not sure which other libraries I tried it with, but yeah, I totally agree with that premise.
Yeah, I've done one. I mean, just using some of the built-in Java libraries, and all you have to do is import them and then treat them as Kotlin classes. And so I would imagine that some of those other things would work that way, but I haven't explored it enough to speak authoritatively.
How painful do you find it when you do call into Java? Because obviously you've got the double bang kind of notation, and there's something else I can't remember exactly what it is. But there's definitely the double bang, which allows you to invoke Java APIs and things like that, which could potentially return null, but you don't know if it does or you don't know if it will or not.
Right. Well, the double bang is saying, I guarantee that this is not null.
From the user point of view.
Yeah. Well, everything I've seen has been quite effortless to call Java, but again, not a huge amount of experience with it, so I wouldn't want to try and say too much.
Okay. Oh yes, actually, there was. It seems a long time ago. Actually, someone's just reminded me there was an earlier session about Kotlin and Spring Boot, and that was actually in the APAC version. That was That was at 12. That was at 12 midday in the UK time. So almost 13 hours ago. That's probably why I don't remember it. But yeah, double check that.
And next week at the Kotlin conference, which I'm attending, they're going to have something on, I think it's Spring Boot or whatever, and so that will probably, and those, as far as I understand, those all of those presentations will be online fairly quickly after the conference.
Awesome. Any other questions from Montreal?
Yes. The mic is open?
Yeah.
Okay. You know, in Groovy, you can be in a project with some Java sources and Groovy sources, for example, and you can do some cross compilation, meaning Java code can directly use classes made in Groovy. So, is it possible also in Kotlin to do that?
Yes. So, for example, if you create a data class in Kotlin, you can use that data class in Java, and you get all the benefits of it. It affects, it more or less looks like a Java bean, but it's got all of the hash codes and equals and compare to and all that stuff built for it. So if you want to use that in Java. They're trying to make it so that it's very easy to incrementally work your way. You can have lots of Java code and just a little bit of Kotlin code and get the benefits from Kotlin without forcing you to just change everything. That's one of their goals, is to make that transition gentle and experimental.
Okay, so it's not like Scala where.
Right. Yes.
Okay.
Yeah. No, they really wanted to learn from Scala as well as lots of other languages, and try and their goal. I mean, Scala is an experimental language, and they wanted to try lots of different things, which is great. But Kotlin is looking at it going, we want to be super practical and we want to be easy. We want to make the transition from Java to Kotlin and back, if necessary, easy. And so their goals were very different. And they learned a lot from the Scala experiment.
Another question. I know it's really strongly statically typed. Is there a dynamic feature somewhere, or?
Well, I mean, there's you have runtime type identification. So you can do things. You can definitely do type checking at runtime, and but I guess you can't do anything. Not say like you could in Groovy or Python, and it doesn't have. I mean, might in the future, but it doesn't have, say, structural typing. But you can do. I don't know. I mean, I think they've created a nice balance. Is that most of the time it seems like it'll do everything that you need it to do. And I haven't really come across, I wanted to play with structural typing because I'm fascinated with that, but it doesn't, most of the time it's not really necessary. That's just an interest of mine, and I wouldn't call that a real issue, because it's pretty flexible, but yes, it is also, like most functional languages, are very strongly statically typed.
Okay, we've got to leave it there. Unfortunately, it was a great conversation. I'm sure there's like another hour's worth of Q&A we could probably do on this. It's really interesting. We've got to jump to another session in just a minute. So I'll just leave by saying a massive thank you to Bruce Eckel.
Sure.
For joining us and for doing all the prep for this session. It was a wonderful keynote, and we're really pleased to have you keynote and join vJUG24. So thank you very much, Bruce.
All right, thanks for having me.
And also a big thank you to the Montreal JOG as well. Thank you for all the Q&A, and you're more than welcome to stay on if you have the room booked. So thank you very much for joining us.
It was a pleasure. We'll probably go for a beer now, I think.
I wish I could join you.
My fellow JOG leaders around, and all the nice people from Montreal. See you later.
See you. Thank you.